Okay, now we're going to see some more examples that are typical of what you're going to find in the homework. First one, the rate of blood flow in an artery is directly proportional to the fourth power of the radius of the artery. K is the constant of proportionality. And they want us to write this relationship as a power function. We have all the tools we need. We just need to put it all together. So the rate of blood flow, we'll call that capital F. In an artery is directly proportional. We know what directly proportional should look like to the fourth power of the radius. Let's call radius R. This we'll definitely have to deal with of the artery, and K is the constant of proportionality. So we don't have a number, but we have a variable K. Okay, let's translate this into the algebraic relationship. The rate of blood flow, F, in an artery is, I love the word is in math because it usually means equals. The rate of blood flow in an artery is directly proportional to the fourth power of the radius. If this is the radius, what does the fourth power of the radius look like? It looks like this. And if we're directly proportional, we should have some constant of proportionality right here. Oh yeah, they say K is the constant of proportionality. This is it. F equals K times R to the fourth is what they're looking for. This is the relationship in those words. Okay, let's try the next one. Length of a box L is with equal height and width W is inversely proportional to the square of the width W. The constant of proportionality is 4. Okay, length of a box L with equal height and weight width W is, this is our equal sign, inversely proportional. We know what that looks like too, to the square of the width W. The constant of proportionality is 4. So length of a box, and this part is just describing, is kind of an attribute of that box, that it happens to have equal height and width. But that is not really going into the algebraic relationship. Length of a box is inversely proportional. Okay, so it's got to hopefully have the input variable down here. Inversely proportional to the square of the width W. What's wrong with just putting this right here? It is inversely proportional to something about W, but it's not just plain W, it's the square of the width. So the square of the width is W squared. They tell us the constant of proportionality is 4. This is it. This is the relationship. Okay, next one adds another layer. Your weekly earnings W are directly proportional to the number of hours you work, H. If W equals 318, then H equals 40. Find the constant of proportionality and express this relationship as a power function. So the new thing here is we actually have to find the constant of proportionality, but we have all the pieces we need. Directly proportional. W is directly proportional to H. W is directly proportional to H. We just don't know this guy. But they do say that if W is 318, then H equals 40. So when W is 318, H is 40. And this is an equation we can just solve for A, the constant of proportionality. So A, just divide both sides by 40. A equals 318 divided by 40. Let's see here. 318 divided by 40 is 7.95. Okay. Find the constant of proportionality, did that, and express this relationship as a power function. So W equals 7.95H. Your weekly earnings are equal to 7.95 times the number of hours that you worked. This is obviously an old problem, or else it's a problem that dealing with what I pay my children to do work around the house, not even this much. This is the end result. This is one that was added a little later because we actually had to find the constant of proportionality. But look out for different phrases. You're going to see fourth power of the radius, the square of the width, you may always also see, if I said that y is directly proportional, oh yeah, all of these use that phrase instead of variation, directly proportional to the square root of x. I've seen people get tripped up on this a lot. How would I write this? Y is directly proportional to the square root of x. Too many people make this mistake. It's definitely not that. That is y is proportional to the square of x. But if you're saying y is directly proportional to the square root of x, your relationship needs to look like this.